become frustrating when you need to adapt to business change. You'll often need to rewrite portions of your application. In this talk, I'm going to show you how to avoid deploying updates to your application by decoupling it from web APIs, transforming your app to be simpler and more robust by keeping business logic where it belongs on the server. For those of you who don't know who I am, my name is Kyle. I'm a Swift developer. I work for a company called Apairy. We're a platform for designing and building web APIs. I'm going to give you a talk kind of fitting on the subject. I'm going to be talking about consuming web APIs on the mobile side and how we can communicate with our APIs in a way that allows us to embrace change. So throughout this talk, I'm going to use an example application I built called Polls. Now, I built both the API and the application. It's an iPhone and iPad app, all written in Swift. It's an application that lets you view a list of multiple choice questions and allows you to vote on them, like your preferred choice. So let's walk through how the application looks and get started and show us what we can do as a user. So when you open the app, you'll be presented with a list of questions. For example, favorite programming language. The application lets you swipe on each question, perhaps to delete it. To view more information about a question, you can tap onto the choices. Tap onto it to view its choices. So there's a question, bacon, and the choices are British bacon, Canadian bacon, or US bacon. You can clearly see there's one in here. And you can tap on one of those choices to vote on it. And then it votes. You can go back to the list of questions where you can then hit the Create button on top right. Here it will let you create your own question. You type in your question name, and you add all your choices. So our application is built around a finite state machine, looking like this, which we've copied from our API, since all of these features are hosted by our API. So how does it work? We've seen what the API does and allows you to do as a user. Let's take a look at how it's implemented, specifically how the application communicates with the API. So the initial list of questions comes directly from the API. The API will do a get HTTP query for /questions method. And we, in the application, have an assumption that this API is going to return us a JSON representation of the questions resource. And we will need to build a logic to handle pagination on our API. When a user wipes delete, we're going to be sending a delete HTTP method. We're going to construct a URI for each individual question to perform this operation. Now, again, to download the question, we will need to construct the URL with our ID, which is server-side implementation details. It's about the relational database ID, which in an application we really shouldn't know about. And when a user taps on a choice, we again need to construct a URI, this time using two of the IDs for the question and the choice. So we would need to duplicate the business logic on our API if a user can vote on this or not. We need to make a decision on that in the application. When we create a new question, we will show a form that allows the user to enter their question. And we assume that we can send this information to the API. And we assume that the server will accept it as JSON. Now, it's clear that our application has been built around an out-of-bounds specification. We've developed our API in a certain way because of our deep understanding on how the API currently works, by looking at perhaps the API documentation or some kind of specification. At compile time, we've made a lot of assumptions about how the API will work in the foreseeable future, which might not be correct. So by designing our application around an out-of-bounds specification, we've extremely tightly coupled our application to how the API will work. The state machine I showed you before, how the application works, is hard-coded into the application. Now, this might not seem like a problem initially, but eventually you'll need to change something. Late one day, your boss comes over to you, probably on a Friday afternoon. Your boss shows you this application that you built, and he says, you might instantly notice here, we have a question with a single choice. Well, you're thinking to yourself, oops, I made a mistake there. I forgot to validate, ensure that the user must create questions with two choices. And your boss might then say, I'd like to change how the application works. He then may give you a bunch of questions, like feature requests or change requests. And I bet we've all made mistakes like this. So he's now asked us to add validation to create a question with a minimum of 2 choices. You might agree this is also a server-side bug, because the guy on the server side allows you to set these when you create them. You might also be asked to change some other functionality. For example, if we want to add a minimum or maximum length to a question or a choice itself, we don't really want to hard code this into the app, since it may change when management or something like that decides that the length should be changed. Perhaps we launched the app, we thought it would make sense for anyone to delete a question. We may later want to change or adapt this logic. Perhaps users were deleting good or valid questions, and we want to prevent them from doing that in the future. We perhaps might want to change your delete so you can only delete your own questions, not other users' questions. In our API, we've seeded it with a base set of questions. So when we created the API, there's like 10 or so questions we put in there from the start. And perhaps we want to make it so users can't delete these questions. Or perhaps we want to change it so when you hit vote on a choice, you can only do that once per question, because currently you can vote as many times as you want. Or perhaps you want to change vote so any new votes override old votes on a question. So if you change your choice, it will remove the old vote and add the new vote. And perhaps we notice spam or bad questions, and we want to allow users to report these. Perhaps we want to add replace delete with a report functionality. So maybe when multiple users report a question, it then gets removed from the interface. Your answer to your boss is probably something like, this will take some time. Since we've hard-coded the state machine for our polls domain into our application, these rules are all baked into our application, and when we change them, we have to change the app. All of these features are tied around the business logic. You might need to rewrite or adapt your existing code base to adapt to these business changes. This isn't ideal, especially when you need to redeploy your application to the App Store. Not only did you have to spend perhaps a considerable amount of time like rewriting some code, you now need to wait perhaps 2 more weeks for Apple to review it, which any small change can add up to a huge amount of time. If we designed our application around the REST software architecture, all of these things that our boss might have asked us to do should be capable with no changes to the client and only changes to the API. Representational state transfer, it's all about representational state transfer, hence REST. We transfer state representations of state from our server to client. We don't transfer objects or models, we transfer state. So let's take a look at our API and how this relates to our API. So we have an API, our polls API. It can be found at this link or the URL. It's where the base of the API is. And it may offer us some kind of affordances. So when we connect to the API, it offers us one main thing, to view questions. So this is the first state transition. We transfer from the root of the API to the questions resource. Now, the questions list or resource itself may offer us the list of questions, and the API may also offer us the ability to transition to a new state, like entering into each question. Now, just because it can, doesn't mean it will. Perhaps this feature will be removed in the future. Perhaps it will only be shown to a subset of our user bases, be it split A/B testing, or some decision in the API. Admins might only see a certain amount of things, or users, or perhaps per country. Now, each individual question may show us text representations of the question, which is the question at the top. It could also offer us the choices, and then perhaps it would offer us affordances such as delete and report. And then there's the choice itself. A choice may offer us the text representation of the choice. So, for example, Swift, if it was your question of favorite programming language. Then it might offer us the number of votes that that choice already has. And then it may offer us an affordance to vote on that. So go and perform a vote. So we're doing a state transition. Now, these are the semantics behind our domain. So the semantics behind the polls domain, and they're not implementation details. Our API should expose these semantics to our application. Our application may or may not understand them. So here's the diagram of our finite state machine representing our API. And all these items I just went over are pretty much all represented here. So you start at the root of your API. You can follow the affordance called self, which is basically to reload itself. Or you can go over to questions. So now you're at the questions resource. There's a couple of things available to you. At the top, you can see the create relation affordance. You could follow that, perhaps to create a new question. Or perhaps you could view each individual question in that. Or perhaps you reload itself, or you can go to the first page, next page, previous, or last if there's pagination. From a question, we can, of course, reload ourselves again, but we can form a delete transition going back to the questions resource. Or we could view the choices itself, and from the choice, we can either reload it or vote on it. So we don't have to hard code this finite state machine into our application. We can instead expose it in our API. Now, this is called hypermedia, and it's one of the core concepts of REST, although many ignore it because it's quite misunderstood because it's very brief in Ralph Fielding's dissertation on REST. So in a REST API, you should be able to enter its API via the root URI, which you can see there. And now it might offer us these affordances or state transitions. So here our API has offered us two things. It's the URL for ourselves, so we can reload ourselves. Now it's also offered us the questions URL, so where we can find the questions resource. So here we built a simple JSON structure representing this, the initial items in our API. Now, instead of using plain JSON, there are also a few hypermedia standards, and one of those is how. So let's quickly go over that. How is a simple format that gives you a consistent and easy way to hyperlink between resources in your API. So adopting how will make your API explorable and documentation easily discovered from the API itself, because you're just following links. So in short, it will make your API easier to work with and therefore more attractive to client developers. There are some good examples in the wild of using how. So I think some of GitHub's API now uses how, and also PayPal's API uses how. And how just simply expands your JSON structure you would have. So you'll have a normal JSON object or document, and it adds two fields to it. So top left is your existing JSON properties. Then the right, you have your links. And then below it, you have embedded resources, which I'll go over a bit more in a bit. So how structure might look like this. So our API actually understands how. So if we was to connect to it, say we want application/how plus JSON, the API will understand that and return us HAL instead of the simple JSON object. Now, here it's returned us this dictionary with the links in the HAL specification. So we have two links, one to self with the href, and one to questions to go and follow that transition. Now, how lets us embed other resources instead of just linking to them? The embedded document will have a relation name. Here we have two embedded documents with a relation choice. So these choices themselves are full how documents too inside the self, so they have their own URI and all the information. So a smart client will look in the embed area before it will follow a link, which means that a server could optimize and embed any resources it wants to at a later date. A client will benefit from this. So the API team could notice certain clients are always making the same requests. It could optimize them together and put them in the same resource with HAL's embed feature. This can prevent additional bandwidth and additional requests. Now, another great example of using HAL is pagination logic. We don't really want to put pagination logic in our client. We can instead just follow the links to next, previous, self, first, etc. We just follow these links. The API tells us where the next page is. We don't know the implementation details about, do we add page equals 2 or 3 or whatever. Now, along with HAL, there is also Siren. Siren is a hypermedia specification for representing entities. As HTML is used for visually representing documents, Siren is a specification for presenting entities via a web API. Now, Siren offers structures to communicate information about your entities, actions for executing state transitions, and links for client navigation. Siren allows you to define actions along with a name, URI, and method. Now, this is slightly more powerful than HAL because we can express more information. So here we've expressed that we have a relation called vote. So to do a state transition called vote, we would make a post request because it's mentioned in the JSON payload, and the link to do that. Now, Siren allows you to express the fields of attributes that you may use to follow transition. For example, you may send these fields, which are, it tells us what we send. So it tells us we need to send a question and traces, and it tells us the type of document they are, as well as localized titles for the interface. And it also tells us what content type it expects us to send out, like a suggestion. So here it's told us it expects us to post this using application JSON. If a client supported multiple content types to send data, the client or the server could change what it sends here, and the client should adapt. We don't need to hard code these implementation details into our application. Instead, we can learn them at runtime. Now, I've built a simple, lightweight hypermedia API client in Swift, which allows us to use both HAL and Siren hypermedia types with the same interface. But unfortunately, the content types I've shown you may mean you need to design your API in a hypermedia way, and you need to offer these state controls at runtime. Now, unfortunately, you might not have control over your API. But luckily, I've built this tool which allows you to sideload an API description into your application dynamically. So you're pulling in the state machine of how the application works without writing the code for this in your app. So for example, API Blueprint is a language that you can use to describe an API. So it allows you to design and communicate your API before building concrete implementation. Now, since this format is based on Markdown, it's one, user-friendly, but two, it's machine readable. So there's a parser, so the client can actually download this file and understand all the semantics behind it. So it can look at the top and say it says /questions, and we need to post that. Now, Hyperdrive allows us to enter an API by its root URI, or via an API blueprint. So we can determine how the API works at runtime, since how the API may work may change since when you deployed your application. Hyperdrive provides the same interface regardless if you're using HAL, Siren, or API Blueprint. So when we enter our API, we pass in a closure to be executed asynchronously. Now, when the API request succeeds, we give back an object called a representer. Now, this is a canonical representation of the API resource. In this case, when we enter the API, we're going to be giving back the canonical interface to the root of the API, which offers us the transitions to go and view the questions. Now, the representer is a real simple structure, it just provides these models. So let's jump into a playground and see how we can use hypermedia to communicate with a proper API. So just give me a second to set this up. That's fine, it's just slow. Waiting for good old Xcode.
Works?
Yep. So is this all readable to everyone? Can you see it? Right. So at the top here, we've basically initialized Hyperdrive and then said, let's enter this API at localhost // port 8000. So we're going to connect to my local server running on my computer. And what we're going to do here, we're using reactive Swift just because it's simpler in this demo. So we can subscribe to the result of this operation, and when it finishes, we're going to call our function print representer, which I've put further up. It basically just prints all the information available. So right away, let's bring this up so you can see it. But basically, if I hit play, so it's going to connect to this URL, hopefully. Yep, and then it's told us what the API offered us straight away. So it's offered us 2 transitions straight away, questions and self. Now, let's add some code to follow that transition. So I've already written it. I'm just going to copy it over. So I'm going to inject it in between these 2 lines. So we enter the API. We're then going to follow the questions transition and then see what that offers us afterwards. So I've hit play now. Now, what it's done is it's printed all of the information available. So it's given us all of the questions. Now, at the very bottom, which I don't think you can see, it says there's transition to create, self, and first. So let's follow the create transition. So I'm just going to add that line after our code we used to follow the question to go there. So we have the existing code. I've just added follow create transition. So what it does is it says, let's follow this transition create that's on there with these attributes, which is just question, types of eggs, and choices of hard-boiled eggs or soft-boiled eggs. So now if we hit play, it should follow that transition. Now you can see it's created this new question with the 2 choices which have 0 votes because it's brand new. Now we can make the following transitions. We can report, because I've added that feature to the API. We can reload itself, or we can delete it. So what we can do is quickly use one line of code, which I'm going to paste afterwards. And what this does is it selects the first choice which is embedded in that response from the API. So now you can see when it loads, it should say the choice, the hard-boiled eggs. We can do the following transitions. We can reload itself, or we can vote on it. So let's make a vote, which is just one more line to follow the next transition. So you can see it's really easy to follow transitions without us writing any code that knows about HTTP, or even Siren, or HAL, or JSON. So we've added the one line to vote on the choice, which just makes the request for the transition that we've been given. And now you can see the votes has gone up by 1. And we can also follow vote again, because that's how our API is currently implemented. But what I'm going to do is let's go back to the previous state. So I'm going to remove that vote in our code, and also actually the selecting the first choice. So I'm just going to replace it with, instead of doing that, we're going to just follow a transition called delete, which will then delete that newly created question. So I hit play. You can see it's now taken us straight back to the list of questions. And you can see the first question is game genre, so it's deleted our newly created question. So let's quickly dive back. Right, so let's recap what we just achieved. So without any knowledge about implementation details about our API, we've connected and performed various operations. Now, we've done this just by knowing semantics. We've just known these relation names and keywords. Our code base doesn't need to assume that functionality exists. Instead, it can utilize this information at runtime. So we can check whether we can create a question before showing that button. So if later date the API wants to remove this functionality, we can. And we don't assume that a user can delete every question. We instead allow the API to offer us this transition, and we will show the UI for deleting if it's there in the API. So when the API removes delete for whatever reason, perhaps it wants to change who can delete or business logic around it, maybe split A/B testing, it can do this without us updating the client at all. Now, we can go even further than this. We can surface unknown affordances to the user if we would really like. Although this is possible, it might rarely be a good idea. So here we have a More button on top right of the app. You can see the 3 dots on top left. So inside the question itself, there's this More button. And this More button is shown when there's affordances that we don't understand. So the application hasn't been updated to support the report vote question feature earlier I mentioned. So here we can tap on this More button, and it shows us the 2 affordances we can do on the question. And one of them is report, which we don't even know about. We're taking the title directly localized from the API. But delete we do know about. We understand the semantic meaning of what delete is. So what we've been able to do is mark it in red because we understand what it is, and we've represented it this way. And that allows us to just add features to our API without client knowing about it. And we can go another step as well. So we can populate form fields from the API without hard coding them. And we can also perhaps download JSON schema from the API to validate our resources when we want to create things. So for example, earlier I mentioned the application lets you add 1 choice to a question, which is obviously a bit silly because there's only 1 choice. You have to really cast correct votes on it. So for example, we could download the schema for this from the API, and you can see at the end of the choices line, we could add min items to that. And then if this was all powered from the API, we could change it in the API, and the application doesn't need to be updated for that. Another example could be like a login screen. Perhaps there's a minimum length on passwords, and you have a requirement that you want to locally validate that before sending it off to the API or hitting the login button. You don't really want to be shipping hard-coded minimum password values in your application, especially when they might change and people might be locked out. So everything I've just shown you today is open source, but it's you can easily implement this kind of thing however you want. Or you can follow standards like HAL and Siren. So here's some links to repositories on GitHub, which contains Hyperdrive, a couple of things related to it, and also the polls API and app, because that completely exists, all open source. I'll be sharing a link to these on Twitter shortly. And if you liked what I presented here, please feel free to get in touch with me. It's my email address. I'd love any feedback. So that's it.